Hello, my name is Jim Mullaney from SciTech Process Solutions. Today is Thursday, July 19th, 2018. Today I'm doing a video source inspection on a fully remanufactured 870S spin rinse dryer. We upload our videos to our YouTube channel for the customers to review. So because of that, we do not give their name out in the video. However, this company is in the United States and their purchase order is MS163009. The options on this tool are the DI resistivity, the DI recirculation, the static eliminator, and then also rotors for an A8239MU and an A18260MB rotor balanced for 20 wafers. Let's go ahead and check the options first before we do anything. So I'll go to the back and I can see the water recirc valve here. It's a gray valve that allows the adjustability of the customer. They can have it as full flow if they want the water recirc or just do a trickle. As many people in fabs know, the water recirc is to allow a non-dead leg status of the tool. When you have a dead leg, there's lots of history that will cause bacteria growth. Let's look at the other option back here. And do I see? Yes, I see the resistivity probe in the drain box. So that's the resistivity option. And then let's look for the antistatic modules. And I can see them right there. They're about 11 o'clock in the bowl. The rotor, A18260MB. This says PA18260MB. That's cross-compatible to an A18260MB. That just means the material is, P means poly, but this is Teflon, and it's balanced for the 20 wafers. The rotor down here, that is for the 4-inch cassette. And that cassette is A18239MU. And that's got 20 wafers also. Okay. Put those back in. So what I'd like to do is I'm going to go ahead and start the process just to get the tool running. And then what I'll do while it's running, I'll review our remanufacturing process. And next to it right here is another tool for another customer. It's in final test. It's going to probably be ready tomorrow. It's been here for a few days. This one has the skins off, and when I review it, I'll explain how the sequence of a rinse dryer goes through our remanufacturing process and why it has skins off here. Okay, so this also includes the state-of-the-art SLITech, the Slick Device S1 graphical interface intelligent controller. This is the smartest controller available on any rinser dryer in the world. I'll go ahead and review some of this. What I'll do is I'm going to review the controller at the end of the video. That way I can get this started and we can do a final end video. So, as you can see, you simply load your wafers like they are. Actually, why we do that before I start, one thing I should show because it's running, you can see the quality of the bowl. We actually, in our rebuild process, we have a bead blast process and a re-electropolish of our bowl. I'll talk about more things we go through the EP process. EP means electropolish. But I just want to show you the quality of the bowls, and they look great. So you load the cassette. You load the cassette, which are both in there. This recipe is a very simple recipe that's used around wafer fabs. Rinse is 60 seconds. Purge is 10 seconds, dry 1 is 90, and dry 2 is 300. What I'll do is I will go ahead and talk about these steps as they happen, why they're important, and then when we get into the long 300, that would be a 5-minute dry cycle, dry 2. That's when I'll review the other tool in our remanufacturing process. So you simply hit start. Okay, so we're in the rinse cycle. What I will show you, because the Slick Device is running, when you're in a step on Slick Device, green means on. So right there you have your LPP, which is low pressure purge. That is a low pressure N2 purge into the bowl. And then you have the rinse valve. Both are on, and you can see in the graphical display the water spraying. What happens is the next step is a very short purge. What that does is it blows N2 through the DI nozzles to make sure there's no water to be dripped back in during the longer dry process. You'll see that in a second. Our system, as you can see, we're in the rinse process. That's the countdown timer. That's the timer. And that's what the total step was. As you can see from our front panel, the date and time, it's 5:47 p.m. on 7/19. And you can see the resistivity monitor is working right there. Okay, now we're moving into purge cycle. Well, as you can see now, the N2 is on and the purge is on, which means the rinse valve is closed, so we're blowing air through the system. As you can see, how fast we ramp up. Our system is a smart learning controller, so it learns the RPMs. I will talk about that right now. that the traditional rinser dryer, if your amp or your brushless motor start to get old, in which they fatigue, then our system monitors that, learns the new power needed every time, puts it in memory, so when next time you run the process, it can quickly ramp to the required RPMs, because it's a smart learning controller, not what we'd call a dumb controller like almost all the other dryer controllers in the world. Okay, we're in dry 1 typically in the process that are used in wafer fabs. Dry 1 is a high RPM process. It's meant to sling the water off of the wafers, the cassette, and the rotors, and then it also has the hot N2 and the bowl heaters on. It's meant to be a short process, and then it'll go into dry 2. Dry 2 is an elongated process where you have the anti-static come on, the bowl heater come on, the N2 heater come on, and then you still have centrifugal force. There was many studies done for particles in the industry over the last 20 years. If you can minimize your RPMs, you tend to always have better particle counts on your devices. So I'll wait the 15 seconds and you'll see it ramp down, then I'll move into our remanufacturing process. As you can see, look how smooth this is. In fact, you don't even hear it running. It's a beautiful machine. We are the #1 remanufacturer of the highest quality spin rinse dryers in the world, and you can tell people think our tools are new. We were at Semicon show with our booth this last week, and people came up asking if we had a new rinser dryer in the market, because the quality was as good as any one you can buy. Okay, as you see, we're dropping down the RPMs, 500 RPM, 500 RPM. Okay, now you can see what's on. The N2 heater's on, the LPP valve, the N2 heater, that's the N2 valve, the N2 heater, the antistatic. The bowl heater is yellow right now. What that means is that we monitor the process switch, and when the process switch closes, which means it wants heat, it turns green. When it gets to temp, it opens up, it turns the yellow amber color, and then when it cools down until it goes under temp, and then it heats back up again. So you'll see that go on and off a few times. Okay, so what I'll do now is I'll talk about a manufacturing process, and I'll use this system right here. At Cytec, we don't care what kind of system people buy. We are the premier remanufacturer, so we can rebuild any type system, a 2-inch system all the way to 300 plus millimeters. What we do is in our manufacturing, we would take a system like this, let's say it was the tool, tear it all the way down to the base metal parts. We do a chemically clean and send out the critical parts for electropolish and the bead blast in the bowl. We go through and electropolish all of our N2 manifolds. We found that's huge in particle control. Then what happens is we go through and we rebuild the motor, rebuild the ACR valves, replace the Humphrey valves with SMCs. We rebuild the rotor stop positioner. We test or replace all of the 8 and 20 PSI sensors. We put new filters on. We then put in new Teflon lines for both N2 and DI. We put brand new pneumatic lines for the ACR valving and for all the doors. We replace the the window and the window seal. So basically we build a tool up from scratch. So we pre-prep all the parts, then we start building it up. We build it up on our stainless steel tables in our manufacturing area. Once a tool is built up, we have a quality control checklist that is then confirmed by another technician. If the head passes quality control, it then moves into wet test. If it doesn't, for any reason, it is reworked and then tested again. When it comes into wet test, it comes in just on a stainless steel table, not like this. Then we hook the DI water up to it without any of the outer skins or any of the frames. We then go and make sure all of the lines are tight, all the ACR valves hold, everything's good. We go through approximately 50 process runs. Then we have another QC step where another technician comes in, which is a fresh set of eyes, reviews the quality checklist to make sure everything's good, and signs it off. If it passes, it's then put into our configuration. This would be like in this system called a double stack. That means an 8. This is called an 870. The 7 means it's 6-inch capable. The 0 is just the 0. There is no rhyme or reason behind that. And this is actually an 880 because it's an 8-inch tool. So we put it into the system like this. We install the slick device controllers, our light indicator modules. We go ahead and install the amps and then check it for quality control. I didn't talk about the frame. We go out and we chemically clean and the frame, and we actually have our own poly shop here at Cytec. So any poly that's yellow, discolored, scratched, anything that has defects that we don't think are appropriate, we have our poly shop make new. That's why our tools look like they're brand new. So then it's in this configuration now. This system has been through now another 50 process runs. It'll have a quality control tomorrow morning. Once that's done, we'll go ahead and put the skins on it, and it'll be released to sales for a video. One of the things I want to talk about, and you can't really see it too much from there, is that we at SciTech pride ourselves on our spare parts. We're the #1 spare parts supplier for semi-tilt spin rinse dryers, a non-OEM in the world. So what we do is we have a SciTech label on all parts so the customer knows how to replace them. One of the downsides of the past SRDs is there was no part numbers on them. You didn't know what the valve was, so you had to, so what SciTech had to do is put pictures of all configurations on our website, send those to our customers so our customer could figure out when they needed a part what to buy. So as you can see, we have our part number here, 06-00632. That's for this ACR valve. We have a part number here for our brand new filter. I have a part number here for the 8 psi sensor. I have a part number here for the antistatic module. We have the part number stamped on for the SciTech process heater blanket. Another part number for the ACR. Here's another part number for the 20 psi sensor. On top here, we give you the part number for both the replacement SMC valves and the SMC manifold. We have the part number on the rotor stop positioner. I can see our tag and our large part number on the brushless motor. Down below on the amps, I can see the part numbers there. So you can see every part that's basically a consumable part or can be replaced over time. SciTech tries to document what the part is. On our slick device controller, okay, on the back we have them serialized. This one is on the top one 613100153. It has all of the correct documentation. We also secure our controllers down prior to shipment with a tie-down wrap that can be left on, it can be taken off. Our controllers are CE marked for international shipments, so we have full CE certification on the controllers, and we actually have full certification for any rinse dryers that we ship international also. So that gives you an idea. Okay, so sorry about that. I was talking a little bit long. I missed it. At the end of the process, it's called the rotor stop positioner. It's called RSP. It's a system on the back that has a valve, and it extends out almost like a plunger. It then hits against the cam. The cam is what attaches to the rotor, and it turns it till it hits the flat, which we call uprights into home position, which is 12 o'clock. Then what happens, the door releases. As you can see, it's open now. Open. And whoops. Okay, so on our controller, at the end of process, it said it would have said if I showed you process complete. You can either hit accept, and that clears it, or you open the door, or you hit clear. Any of those three things will clear our controller to the next step, and it'll change the amber light. Talking about the amber light, let me go into now the controller. So for the menu, recipes. Actually, I'm going to do the bottom one. Might be a little easier for me. Okay, down here. Okay, so if you go into, first of all, if you had an error with your tool, at the end of the process, we'll come up with an alarm. This alarm will flash. You push on it, and if there's any alarm on the process, it'll be lit up red. We monitor the DI probe, the door, the bull heater, the antistatic module, the RSP, N2 heater, N2 pressure, motor tack assembly, and servo amp fuse for the servo drive. Again, you can see all those are black, which means they're all good. If you had a problem and the operator said, my servo amp fuse has an issue, and they probably wouldn't know what it is, they simply hit maintenance needed. Maintenance needed puts us into a cycling color. This means that the tool is down offline for maintenance. So an operator comes over, the bottom light is for the bottom rinse dryer, the top light's for the top rinse dryer. So this lets people know the system's down. If there was a straight alarm, also at the end of the process, this would be red. But there was no alarm on that. And the maintenance engineer comes over and says, okay, I got a problem here. I turn this off. When we're not, amber means you're ready to process. Since we're not in the main screen, the light goes, turns off, which means you're in the programming or mode. Let's go back to there. Now it came back on because I'm in my main process screen. So if I want to go into recipes, I click recipes. As you can see, it goes off. 0000 is our default code. So you can see your recipe. If you want to change it, you simply click on it, hit it, hit save, and the new recipe comes up. If I went back, now we have 30 seconds. And as you can see, we went back to the main screen, so we're there. I'm going to go back to the recipe. So SciTech has, in our controller, 20 recipes. Plenty of recipes for any fab in the world. As you can see, you can scroll through. We put just a standard default recipe in all of them. The last the last three recipes are for the auto cycle. Some customers want their tool to run a rinse cycle when it's idle for a long time, and you can program that in our system, and I'll show you how. So that's how you do the recipe management. It's very easy. Okay, if you want the quality rinse, you can turn it on or turn it off. What that means, right now we have it set to 10 megohms. If it doesn't reach 10 megohms in the process, you'll get a resistivity alarm on the main screen. It'll say unsuccessful run, and when you go to the alarm screen, it'll be lit up red. All right, so let's go back out of here now. Save. Oops, and wait, there we go. Okay, so now let's go into the menu. Again, the menu is where operators probably won't be. This is for a process engineer and maintenance. You have 2 password levels, so we still have this 0000. Okay, you have settings, recipes, manual mode, auto cycle, N2 settings, alarms. You also have the log, static, controller, and cleaning. The log, what that does is we log all the steps the rinser dryer uses and any icons that are pressed. So let's say that someone comes into, and I'll show you, they go into the maintenance, the all manual mode. That means that you're overriding safety factors, and they do something that's wrong. And they try to tell, oh, I didn't do that. The maintenance guys come over, they can run the log, and it'll show someone pressed the button that said, warning, you're going into the maintenance mode. And I'll show you that in a second. It also logs all of your runs, if they were complete or non-complete. It'll give you a history of how many process runs you did in a day, what the total time was. Controller info, that's just us. Talks about SciTech Process Solutions, our development team. Jim Mullaney, Daniel Mullaney, Blake Mullaney, and Jaime Rivera. Here's the software version. Our control number is 906-02000. It gives you all the firmware versions. Our controller is a smart controller. We have a microchip, microprocessor in the system that has to match the screen software. So, and it's a compiled program that cannot be uncompiled by customers. If someone gets in our computer and starts messing around, takes out the master process chip and puts another one in, if the two do not match up when you turn the controller on, it will not allow you to do anything. It'll freeze the controller, and then we know people are messing around with controllers. Okay, let's go back into the menu now. Again. One of the big values of our system is the N2 setting. What this does is a typical rinser dryer, a 70 size bowl, uses anywhere from 5 to, let's call, if it's a $76,000 or $7,000 of nitrogen a year. If it's a 2300, it uses more. It uses close to $9,000, and that's called the LPP, flowing all the time. We have customers doing N2 payback analysis that, on average, most customers, it turns out, don't run the tool more than 15 to 20% utilization in a 24-hour day, which means you're losing 80% of your value of nitrogen just purging when there's no one around. What you can do in our system is at the end of the process, when the door's opened, after it closes, you can set the time. How long of delay before we turn the LPP off? And then you can also say, some customers have said, you know what? I want to have a purge every once in a while to keep my bowl a little pressurized and clean. You can program this. It says, okay, every 3 hours, I want you to come on and run that 20 seconds again. We also have called the N2 heater cool down. The reason is that the N2 heater on a long dry cycle gets very hot. And we've done studies that 20 seconds wouldn't be enough to really cool it down. So we have a pre-programmed extended time that if you run a process that's more than 5 minutes of dry, actually it's more than 9 minutes total, that the auto cooled on, if you have it on, automatically goes into effect. If you don't want to use the N2 saver, it's on or off. I'm going to turn it on because right now it's off, and that's all you have to do. And I'll show you how that works in a second. Okay, the manual mode I talked about. Auto cycle, let's do that. Remember I talked about that? So you can say, I want the auto cycle to come on every 25 runs. Or actually, this is you can say every 5 runs or every as many as you want to do. You can also then pick a recipe for it to run. You can say, I want it to be every 7 runs, 8, 9, 10 runs, whatever you want to do. So I'll get out of that now. I don't need to. And then I'll back up. Okay, this is it. Manual mode. Here's your alarm. Warning. Security interlocks are being bypassed. This should be by trained personnel only. You have to say, I read and agree. We document that button being pushed in our log so someone can't say they never got into this. What we can do here is one of the huge features of our system is our circuit test. We monitor the antistatic module, the N2 heater, and the blanket heater. One of the key things, one of the main enhancements of our controller is that we have a special DDL algorithm generated by SciTech that has a way of letting you know if your antistatic module is working. It's proprietary, so we can't go into how we've done it. but it monitors it, and you'll see in a second. The problem is, most people, if they have a traditional rinse and dryer, they don't know their anti-static module went bad. In fact, if you look at a system and says, to test your anti-static, use a high voltage probe, that doesn't tell you it's working. You might probe, oh yeah, I have high voltage. Probe, I have high voltage. There are some characteristics of an anti-static that have to happen inside that just because you have a high voltage on the probes doesn't mean it's working correctly. That's part of our DDL algorithm. What happens is that if it dies, wafers get processed up the line. All of a sudden you have yield losses, and that might be 4 or 5 steps, 10 steps ahead, depending on when they do the particle checks. The maintenance and equipment engineers have to work their way back, spend tens or hundreds of hours finding out where the problem happened, how much yield loss they had, how many lots they lost, and then work their way back somehow to figure out the anti-static module on the rinse and dryer is bad. Our system, off one run, it'll tell you. So at the end of the process, it'll come up with an alarm, anti-static failure, so you can stop the process, take it to another rinse and dryer, or reprocess the wafers so they're clean, and move on and put it in maintenance mode to be fixed. So you can monitor. If I was a maintenance person, I want to check it. Okay, there's our DDL algorithm. These numbers are proprietary, so I won't go into it. But as you can see, it's passing, passing, passing. If it didn't work correctly, it would say fail, and that means your anti-static module is bad. Let me turn on the N2 heater. That's the N2 heater, the power consumption. What would happen is, if the N2 heater was bad, you would have 0. It would be a dead because there's no power consumption. It would be a straight line. We call it flat line at 0. I can also check the bull heater. Okay, the bull heater is red. The N2 heater is yellow. It uses a different amount of power, but you can see they're both running and they're both consuming the needed power, and they're not failing. A very easy test for maintenance people to do PMs on a monthly basis to make sure the parts are working correctly. I'll turn those off. Okay, so as you can see, it's a great thing. Also on your process switch, if your process switch was open or closed, the 20 psi was bad, you get an error. Okay, in the valves, if you want to, if a maintenance person wants to check stuff, I hate to do it, but I'll do it anyway because I'll have to run it again. So let's say I want to do rinse. Watch this. Uh-oh, it won't let me rinse. You know why? Rinse valve cannot be activated until the door is closed and seal is also activated. So it's saying, okay, door is closed. Oops, I'm sorry, down here. Okay, door is closed. I'm going to lock the door now. I can't open it. It's green. Now when I hit rinse, if you look down below, because again I'm doing the bottom rinser dryer, notice how it's manually rinsing now. And I'm going to hit turn it off, and it ends. So maintenance now can test if their LPP is working, if their purge valve is working. I just turn the purge valve. I can hear it working. I can turn off the LPP. I can change the RSP. So now there's I got to turn out, open the door. That just opened the door. So now the RSP is not engaged. Watch. So it's upside down. Let me engage the RSP, and now it uprights. So maintenance can quickly check the status of their tool. Motor tach you don't have to get into. Again, I talked about that we have an intelligent controller. It learns our RPMs. In our first versions of software over a year ago, you could actually adjust the speed to match a certain RPM, and it would stay in memory. But we've now made that an automated system. But if a customer wants to test theirs, they can say, okay, I want to see. I'm going to do it again below. Let's see if I want to run my tool. Watch, down below, you can see it's spinning now. Okay. Okay. And then you can turn it off. If I open loop means there's no tach feedback. Closed loop means now I'm monitoring the tach assembly. And look at exactly. We are right on the exact RPM we're supposed to, and that's complete process control on our system. Let me turn this off. And it's braking. It's giving you a warning, do not open the door until the motor stopped and the door releases. What happened is whenever you run this process, it's a safety feature, the door automatically locks. So don't do this if you have the door open and want to run the tool with the door open, because the seal is going to try to inflate and it's going to pop out of the door seal. That's a safety factor. Okay, resistivity. If you want to test the resistivity or do some programming, you can. The valves I talked about, and everything else. So let's go. Now, settings. These are very simple. If you want to adjust the clock, you can. I won't do that. If you want to change the brightness of your screen, you can turn it up, turn it down, whatever you like to do. Manual mode, setting, I've got to get back to settings. Volume, if you want to turn on how loud it is, I have it all the way up. And password. If you want to change your password, here's the current password, and you can then change it to the new password and confirm it. Okay. After the password protection, it goes back to the main menu, but I want to go back and make sure I didn't miss anything here. Oh, anti-static. So some customers might or might not want their anti-static module working. Almost everybody does. If you don't, instead of having to change software, you just click the button. There. Anti-static's enabled, anti-static's disabled. What happens now is when you run your dry 2, the anti-static module will not come on. Okay, and again, I already showed you about control information log and etc. Okay, so as you saw, now we're back to the main screen and it turned amber. Let me show you one thing on the errors. Let me go back here. Where's my N2? Let me grab my, there we go. Okay, I want to show you error, well, but they both erred because they're teed off. Okay, obviously there's an alarm. You notice how we have the alarm there? It says there's one alarm. You click on it. N2 pressure failure. You can clear it and go back, and it looks at it again and says, no, you didn't fix me. So now I'm going to fix you and turn the N2 back on, and the alarm is cleared, and the alarm is cleared. Self-clearing, and now we're back to process mode. So that is a nice tutorial. Oh, one other thing, our USB up port. I know that most fabs do not allow Wi-Fi inside of their, from vendors to have Wi-Fi in the fab. There's a lot of proprietary stuff. If a customer wants to, we can send them a file to load on their PC. They use the USB uplink port. We can then log on to their PC from our back here in California, and we can look at their software. We can look at their process log. We can update the software with new software. Basically, we can do everything like the tools at SciTech brand new, and we can give new versions of software. If for some reason they need, they had an error and they were asking us how to do it, they forget how a log works, we can call us, we can take care of that. But when you do that, you have to push the up button in. It's in now, it's out. That's how you do the upload information. So as you can see, our controller is an intelligent, smart, state-of-the-art, everything you expect from a high technology company like SciTech. You know, to become the world leaders on remanufacturer's tool, you have to build the best tool and the best quality, which we do. Last thing I'll say is SciTech Process Solutions has 100% spare parts support on these tools. If you go to our website at scitechprocess.com, SciTech Process Inc. is scitechprocess.com. On the left-hand side, the first 7 links you'll see are the 3 semi-tool spinner and dryers. The S model, which this is, which means it uses the brushless motor and the servo drive. 2 is the brush motor, F model, which looks like this, but it uses the traditional brush motor with a ferrofluidic seal, or the traditional ST, which you see around fabs around the world. And then you can see all the tools we offer, and again, we can supply any version you need. The second 3 links are those 3 same model numbers, but all the spare parts. As I talked about, we have 100% parts on all 3 versions. It's not a problem. The 7th link is our SST and WST spare parts support. We have different boards, parts over the years we've done. You can also see from our website, we have other front-end process tools. We are the U.S. leader in the Integris box washer rebuilds. We do a lot of those. We do a lot of mask and wafer scrubbers. We also do metrology tools, 10-core, DECTAC, KLA, excuse me, across the board. We do high and low power microscopes. We also do etch and plasma processing equipment too. So that will conclude this video inspection of a fully remanufactured 870S spinner and dryer. My name is Jim Mullaney from SciTech Process Solutions. Today is Thursday, July 19th, 2018. If you need any questions, feel free to call us at 916-797-9000 and ask for anyone in our sales organization. Thank you.